Every single second, global flight coordinates, financial transactions, and massive logistical updates generate millions of discrete data points. Left in its raw state, this immense volume of information is entirely unusable. It is a chaotic stream of text and numbers, offering zero actionable value on its own. To capture and organize this stream, systems rely on relational databases. These digital warehouses catch the raw information and sort it into tightly structured, interconnected tables. However, these digital environments are strictly locked. You cannot extract a single row of data or command the server to act without a highly specific method of communication. Managing these repositories requires a standardized communication protocol, one capable of navigating the complex layers of the warehouse. Structured Query Language, or SQL, serves as this bridge. It is the syntax specifically designed to translate human intent into machine-readable instructions for relational databases. With SQL, you convert analytical questions into pure mathematical execution. Mastering this syntax provides the means to filter through an ocean of information and issue clear instructions. Like any language, SQL relies on a set of grammatical rules. Yet its primary syntax is surprisingly forgiving. The core keywords are case-insensitive. Whether you type an instruction in all capital letters or entirely in lowercase, the database engine treats the command exactly the same. But while capitalization is flexible, the structural termination of those commands is rigid and absolute. This diagram illustrates the necessity of the semicolon. It is the essential punctuation mark that signals to the server that your instruction is fully assembled and ready to execute. Understanding these exact syntactic boundaries is the first requirement for safely issuing instructions to the server. Once those boundaries are understood, every data manipulation falls under 4 foundational operations. The first is insert into. This is the initial spark, the command creating a new record, and places it perfectly inside a designated table. The second operation is select. It isolates rows based on strict criteria, pulling exact records forward. Paired with a wildcard asterisk, it extracts every attached field at once. The third operation, update, alters pre-existing data, evolving internal values without destroying the record. Updates require precise targeting logic. Without strict limits, a single command can accidentally overwrite information across the entire database. Finally, delete dictates absolute erasure. It removes a record permanently, forcing the relational structure to collapse and close the gap. These 4 commands do not operate in isolation. They run simultaneously, managing the life cycle of millions of digital records a second. These operations form the base cycle of every record, allowing a user to manage the entire lifespan of information within the database. Beyond moving data around, SQL allows for hyperspecific, granular analysis using built-in functions. String functions isolate and reorganize text. They can parse through thousands of names or addresses and manipulate them down to a single character. Numeric functions instantly execute mathematics, automatically averaging the inputs, summing the total amounts, or pinpointing the maximum values across massive global datasets. Date functions track the flow of time. They extract specific months from historical records and calculate the time intervals with extreme microsecond accuracy. These tools enable the extraction of specific, actionable insights, turning raw storage into an active analytical environment. These commands form the invisible logistics of the modern economy. Looking at the automated precision of a global shipping port, you are watching SQL in action. This syntax forms the backbone of global commerce, shipping networks, and digital communication. Learning SQL is about learning how to ask the right questions of the digital universe. It provides the ability to synthesize millions of disconnected fragments into a single, cohesive observation. SQL provides the framework for human intent to organize and command the digital systems that define the modern world.